In this video, I will demonstrate how to use the templated machine learning solution of the AI and analytics engine to predict customer churn for transaction-based businesses such as banking or e-commerce. I will walk you through step by step how to create an application with the AI and analytics engine and use the app to predict which active customers will churn in the near future. If you run or work for a customer-oriented business, you know how hard it is to acquire new customers. You also know how important it is to keep your existing customers happy and loyal. Losing customers to competitors can hurt your revenue, profit, and growth. That's why customer churn prediction is both a challenge and an opportunity. It can help you increase customer satisfaction, loyalty, and lifetime value, but it also requires a data science team that can build complex and business-dependent data processing pipelines. Not to mention the process is quite time-consuming, could take weeks or months for a solution. What if I told you that you can build a customer churn prediction model without writing any code or hiring any data scientist? This is not an imagination, but a no-code solution that we offer. We designed it to make customer churn prediction easy and accessible for anyone. You don't need any prior knowledge of machine learning or data science, and it doesn't take weeks or months to build, just minutes. Let's see how it works. First of all, we need a specific context. In this video, I'll use a banking service as an example. This will work for other kinds of businesses that have transactions such as e-commerce, retail, etc. We also have another video for businesses that deal with customer subscriptions, which you can find in the description down below. First of all, we need a specific context. In this video, I'll use a banking service as an example. Now, let's begin. Suppose we work for a bank, and we want to utilize the customer data to support a customer retention campaign. The data includes the transactions of customers in the form of a table that you can see on the screen. It has the account identity, the time when the transaction occurs, the type of transaction, the operation, and finally, the amount of the transaction. The key things we care about are the identity of the customer, the timestamp of the transaction, and the amount. Next, we have a table storing customer demographics. Here we only have the date of birth and the district ID. This dataset is optional. The only mandatory one is the transaction dataset. These are the tables of a real-world dataset from a bank. We put the links in the description below so you can download and try it yourself. Now, we are at the project overview page of the AI and analytics engine. Here, you can easily see the Use Template button. We can start building the template app by clicking on it. It will direct us to a list of supported templates. Now, we will choose the customer churn prediction template under the Use Template option. There are two cases for the churn prediction for two groups of businesses. We will go into more detail in the next step. Now we can just hit the blue button to start. We give the application a name and click Create. We are now on the App Builder page. The process of building a churn prediction app will consist of steps as shown on the left side of the screen. We are now at step 1, where we need to select the appropriate prediction type for our problem. The first option applies to predicting churn for customers who have subscription-based services. These are services that customers pay a regular fee to use, such as telecoms or video streaming. For example, Netflix or Spotify are some of the businesses that use this model. The second option is for predicting churn for customers who only have transaction data and no contract end dates. This is common in banking or e-commerce services. The engine will help us anticipate when customers' transaction activities decline so that we can act early, such as by offering promotional campaigns to keep them loyal. Since the data we use is banking transaction history of users, we will select the second option. Here you can see the engine suggests that we need the transaction dataset as the input, with an optional customer information dataset as we discussed earlier. Now let's import the transaction dataset. To see an example of the required format of the dataset, click on Show Data Requirements. As you can see, we need 3 columns in our dataset: customer identity, transaction timestamp, and transaction amount. To add a dataset, we click on this button here and select a source to import from. The engine supports various sources, such as file upload or databases. I'll go with the file upload option for this demo. Then I'll choose the file that I want to import. While the file is uploading, we can just Click Next. We'll see a preview of our dataset here. If everything looks good, we can click Create Dataset. Next, we need to specify the required columns in our dataset. For the customer identity, we choose the Account ID column. If there are too many columns, we can use the search box to find the column name quickly. Then, for the transaction date time, we pick the date column. You can see that the engine automatically filters out the columns that are not suitable. There is only one option left for us to select. Finally, we choose the amount column for the transaction amount. You can also import the customer demographics dataset, if available, to provide more information for the machine learning model. You can see an example of how the data should look like by clicking on Show Data Requirements here. In this sample data, the customer ID column is mandatory, as it represents the unique identity of each customer. I have the file, so I'll select it from my local computer, just like I did with the previous dataset. I simply click on the Add Dataset button and choose the file. The import process is similar to the transaction dataset. Then, we need to specify which column is the customer ID column so that the engine can relate the transaction dataset with this dataset. After that, we can click Next to go to the next step. We have uploaded the necessary dataset so far. To predict customer churn, we need to define what churn means for our business. In the context of banking transactions, churn can be seen as a period of time where customers have a decline in activities below a certain threshold. We need to tell the engine about that period, and also how low the activity level is considered as churn. There is a quick guide that you can find under the View Guide button. Let's take a look at it. Let's say we ask the engine to make new predictions today to see which customers will churn in the near future. If the engine tells us that some people will churn tomorrow, that information is not very useful, because tomorrow is too soon, and we don't have enough time to take retention actions. Therefore, we want to make predictions far enough in advance, such as next month, next 2 months, etc., so that we can prepare for the necessary measures. On the screen, the highlighted period is the period I just mentioned. By default, it's 60 days, meaning that we will predict if a customer will churn after the next 60 days from now, so we have 60 days to persuade them to stay. Then, we need to define a period to observe the customer's activities. By default, it is chosen as a 14-day period after the 60-day period we just defined in the previous step. In this 14-day period, if a customer has fewer transactions than some threshold, let's say 1 transaction, then the customer is considered as churn. Obviously, we would want to change these default numbers to suit our business. Let's do it. For the banking transactions, 30 days ahead could be a good distance for us to contact the customers and offer them promotions, vouchers, etc. So I will change 60 to 30. 14 days for observing the transaction behavior is probably enough. This means that you will count the number of their transactions in those 14 days, and if they don't have any transactions, then we should consider taking retention actions. We can relax this condition, for example, replace 1 with 2, so if customers have 1 transaction in 14 consecutive days, we also see them as churned. That's all for the definitions. Let's go to the next step. This step is about specifying the past timeframes that affect how likely a customer is to churn. To learn more about these timeframes, let's check out the View Guide. First of all, we have this transaction table that shows the transactions over time. I will tell you how we use it and what inputs we need to provide. Let's say we want to make some predictions today for a customer. We will look at their transactions from the last 30 days. We call that 30-day period a historical time frame. We will calculate some statistics from these transactions, like the average amount, the lowest amount, the highest amount, and so on. These numbers are the contributing factors that help the machine learning models figure out how the customer behaves and predict their future activities. We can use different time frames. The engine gives us 3 time frames by default, and you can see them here. These are the time frames. You can add more or remove them based on the business nature. For banking, we might want to look at recent transactions, like the past week or 2 weeks. So I will add another time frame, which is the last 15 days. Then I click Add. We also imported the customer information dataset, so the contributing factors from it are shown here. You can change them if you want. Then we can move on to the final step. This step is quite simple. The engine asks us if we want it to automatically find the best model, or we want to manually select some algorithms that we want. There are many algorithms supported, but for simplicity, I just keep the default options and start building the app. That's all the inputs we need to provide. Now the app will be built automatically, following several steps that you can see on the screen. It runs in the background, so you don't have to keep the browser tab open. Everything will be saved. In a few minutes, you will see this summary page. The app is ready to use. The best model has a prediction quality of 90.4%. This metric is smartly selected based on the problem we are solving, so that it accurately measures the performance of our model. In this case, it is the area under the precision recall curve. We will explore more about the performance metrics later. You can also check the inputs that we gave to the app, such as the datasets and the definitions. The data preparation pipeline is also shown here, as a nice graph that you can view by clicking on each element and seeing the associated asset. You can also access the prepared dataset as a separate dataset in case you want to use it for other purposes or do some analysis. Next, we will inspect the model performance, since it's important to understand the model before we use it in production. In the model summary page, you can see several tools that can help us with that. First, we will access the performance page. As mentioned earlier, the prediction quality in this case is the area under precision recall curve, which you can find in the metric table. Other common metrics are also provided here, such as F1 score. The charts such as precision recall curve and ROC curve are also available. Next, we will go back to the model summary page and check out the feature importance. That will tell us which contributing factors are the most important ones. From the chart, we can see that the number of credit transactions over the last 30 days is the most important feature, followed by the week at the time we make predictions. The lowest amount of transactions over the last 15 days is also an important factor that affects the predictions. If you are interested in exploring the model insights, we have some other tutorial videos covering tools such as the prediction explanation, where we show you why the model gives a certain prediction. You can also verify your hypothesis about the model by taking some sample data, changing the inputs, and seeing how the prediction changes. You can find the corresponding demonstration videos on our channel. Now it's time to make some predictions. Let's go back to the app summary page. Here, click on the Make Prediction button will offer us two options. The first option, as its name suggests, allows us to make a single prediction from some input data. The second one is for the case where you have a regularly updated data source and want to make periodically scheduled predictions. Let's try the first option. First, we will choose the model that we want to use for making predictions. By default, the model with the best prediction quality is selected. We can just go with it. Next, we can import some new data that has the transactions of customers that we want to predict churn for. Or we can use the data that we already uploaded, which is the part of the data that is not used for training or model evaluation. Then we just click Next and run prediction. We can review the prediction configuration in the graph down below here. The prediction is running, and we can also see it in the app summary page. Now we will try the scheduled prediction option. The steps are quite similar to the one-off prediction. However, for scheduled prediction, we need to provide the input data as tables from databases. We will first connect to the table of transactions. I'll choose MySQL as the data source. After entering the necessary connection info, we can click Connect and the table will be displayed here. We will do the same for the table containing the customer information. After that, since the predictions will automatically run periodically, we need to provide a schedule for them. Let's run the prediction every week. That's all for the scheduled predictions. When it's time to make a prediction, a result will be shown in the prediction output area, which will look similar to the one-off prediction result that we have made a few minutes ago. That prediction should be finished by now. Let's check it out. So, it's finished. You can download this result to your device or export it to other sources for related tasks. We can also see a sample of the result. In this table, there are 3 important columns. The account ID tells us which active customers we are predicting churn for. The timestamp column will be the same for all rows, representing the time we make the prediction. The churn probability of each customer is given in the last column. There is also a convenient column churn date so that we can know when the churn event will happen. So that's it. We then can use the prediction results for desired purposes, such as implementing appropriate retention strategies for customers with high likelihood of churn. This customer churn problem is not a simple one. It usually requires complex data processing and model building. However, with the help of the AI and analytics engine, it took us just minutes to go from the raw data sets to insightful predictions. You can try it yourself. We do have a 2-week free trial with the link in the description down below. You are just a few minutes away from making your own powerful machine learning models. Thank you.